Hello and welcome to UE Tips for You. So in this new tutorial series we'll break down Lyra's animation and locomotion system using unarmed animation pack from Lyra's content folder. So in this tutorial series we will set up everything from scratch: turn in place, movement start, movement loop, and also distance matching for stopping our animation. And also we will use additive animations for our procedural leaning. Here you guys can see I'm using additive animations for leaning towards controller direction. And also we will set up pivoting functionality to our character locomotion. So we will use new animation techniques in UE5, for example using animation interfaces, animation blueprint functions, state-based functions, and animation state aliases. We will not use any event graph to derive our animation logic. We will use our state-based functions to drive our animation functionality. And also we will use state aliases for simplifying our animation graph and many other stuff. And by the end of this tutorial series we have this character locomotion with turn in place, pivoting, movement start, movement loop, and additive leaning animation. So let's get started, guys. So here's my default third person project. I have just added the default level, and now I'm gonna open my character blueprint, third person character blueprint. First thing, I'm gonna go to viewport and set the animation class to none. We will create our animation class hierarchy, and I'm gonna set the animation class to none and set the skeleton mesh to if male character. And after that I have added the camera boom target arm length to 275, and also added some camera lag and enable rotation lag at these values. So here's my current player character blueprint. Now I'm gonna go to my character blueprint, select my character movement component, and set the max acceleration to 1000, and also over in braking deceleration walking set this to 1000 also, and also set the max walk speed to 550 for now because we are using the jogging animations. So here's my acceleration and deceleration walking values working. And I have also imported the animations from Lyra's content folder. These are all the unarmed animation pack from Lyra's content folder. You can grab those or get the project files from my Patreon page. So now let's set up our custom rotation for our movement. For this, now I'm gonna go to my character movement component and set the rotation rate to 0, and also I'm gonna disable the orient rotation to movement to false. So this is my forward facing character movement. So we will use our custom logic for deriving our forward facing character movement. For this, I'm gonna go to my event graph, and over here I'm gonna use event tick. So here's my event tick. I'm gonna set my actor rotation, and the rotation will be my, I'm gonna use interrupt 2. The current value will be my get actor rotation, and for the target value, first I'm gonna get my character movement component. I'm gonna get current acceleration value, get current acceleration, and make rotation from X. This will give me the forward rotation of my current acceleration value, and I'm gonna get my control rotation. This is my get control rotation. I'm gonna use delta rotator between my current acceleration and control rotation. So this is the delta rotation, and now I'm gonna break rotator, and for target I'm gonna make rotator over here. So if I simply use this get control rotation over here, which is also a forward facing character movement functionality, if I set the get delta time to get world delta seconds and interrupt speed to 10, if I set the control rotation directly to over here, you can see it's my forward facing working properly fine. But we need, if I enable my capsule hidden in game to false, and also add arrow component over here for debugging the rotation, just disable this. So if I unhide the capsule, you can see my capsule stays always to the control rotation. Where my control rotation is, my capsule stays always to that rotation. But we need offset to 45 and minus 45 when we go forward left and forward 45. Similarly in case of backward left and backward 45, like here I have made in my demo video. So this is the rotation that we want. This offset our character between minus 45 and 45, and similarly backward left and backward right will achieve this functionality. So by this I'm gonna use a curve for this. for this I'm gonna make a new custom curve. Over here in my blueprints, I'm gonna right click and go to my miscellaneous and create curve. I'm gonna create a float curve that will be my direction curve. So I'm gonna press shift and left mouse button to add a key, or by pressing right mouse button and add key here. I'm gonna set the time. For my time, I'm gonna set this to 0 and value to 0. And we will use this curve for deriving our direction values. I'm gonna add a new key over here. So if our direction is 45, we want 45 degree offset. And if I'm gonna add a new key, if our direction is 90, we will want 0 degree offset. So which means if I print string and disable, I'm gonna show this, debug my control rotation. So here you guys can see, if I move it right, my rotation is 90, so which means I want 0 degree offset. So if my rotation is 45, I want 45 degree offset. If my rotation is 90, we need 0 degree offset. Similarly, I'm gonna add key. If rotation is 135, the rotation offset will be minus 45, and if rotation is 180, the offset will be 0. So this is all in positive axis. Now I want all this functionality in negative axis also. I'm gonna add a new key. So if my rotation value is minus 45, I want minus 45 degree offset. Add a new key. If rotation is minus 90, I'm gonna need 0 degree offset. Similarly, add new key. If rotation is minus 135, I need positive 45 degree offset. So if rotation is minus 180, I want 0 degree offset. So this is all my curve for deriving my direction offset for forward facing character movement. So this is the custom logic for deriving our character rotation. I'm gonna save this curve, open my character blueprint, and I need this curve over here in my character blueprint. So for this, I'm gonna create a new variable. I'm gonna call this direction curve. Go to variable type and set this to direction curve or curve. I'm gonna search for curve float here and set the curve float to direction curve. So here is my direction curve in my character blueprint. I'm gonna get the direction curve and use get float value. So by time in time will provide our, I'm gonna delete this over here. In time will provide our delta rotation yaw over here, and get our control rotation, brake vector, brake rotator, and add this to our current control rotation. Adding this offset to our current control rotation, which will give our nice offset with our forward facing character rotation. I'm gonna set this over here. So if I hit play and check, you can see if I press W and D, my character is offset 45 degree in both positive and negative axis. Similarly, my character moves backward left and backward right, and also forward left and forward right. So if I press only D, my rotation offset is 0 with respect to my current control rotation. If I press D and W for at same time, my rotation offset is 45 degree to my current control rotation, and this happens in all 4 axes: forward left, forward right, backward left, and backward right, like so. So I'm gonna save all, and so if I rotate my control rotation, you can see my character rotates in weird way. So for fixing this, I'm gonna go to my character blueprint and put a branch over here between event tick. So I'm gonna grab my current acceleration. So if my acceleration length, vector length of my acceleration is greater than 0, only then we will perform this actor rotation functionality. So if I hit play now, you can see my character rotation stays still when I am in idle state, and my other rotation is properly working fine. So we will add that turn in place functionality. We'll add that rotation when we will add the turn in place functionality to our character. So this is the character movement functionality is completed in our character blueprint. We'll move and our character rotates according to our need with proper offset in all 4 directions. And when we release the input, our character stays at the proper rotation. So this is done. Now we will set up our animation functionality. So for setting up our animation blueprint, I'm gonna create a new folder over here. I'm gonna call this animation blueprints. So we will use proper animation interfaces and blueprints for this. First I'm gonna right click, go to animation and create a new animation blueprint to my current SK mannequin skeleton. I'm gonna first call this animation blueprint underscore animation blueprint underscore Lyra base. So here's my base animation blueprint. I'm gonna save it out. Now let's create our animation interfaces class, animation interface class. I'm gonna right click, go to animation, and here is the animation layer interface. I'm gonna name this animation ALI underscore, ALI stands for animation layer interface underscore Lyra, animation layer underscore Lyra. So first we will, in our animation layers, we only want the specific events. For example, our idle, jog start, jog loop, jog end, pivoting, all that kind of functions we will only need in our animation layer. So first I'm gonna add here, I'm gonna call this full body underscore idle states, and also add a new event, animation event. I'm gonna call this full body movement start, full body movement loop, full body underscore movement. Instead of loop, I'm gonna call this cycles, and full body underscore movement end. So for now we will only need these 4 events. We'll also add pivoting, so let's add pivoting also. I'm gonna add full body underscore pivoting. I'm gonna add these 5 functions over here in my animation layer interface. So now I'm gonna open my animation layer base, and over in my class settings I'm gonna add a new interface here. This is my animation layer interface underscore Lyra. I'm gonna add this interface over here, and by adding that, you can see over here in my animation layers I have all these 5 functions available here, like so. So now over in my animation graph, I'm gonna add a new state machine, and I'm gonna call this Locomotion state machine. I'm gonna add a new inertialization node here and connect it over here. Go to my Locomotion state machine, and I'm gonna add a new state, and I'm gonna call this idle. So this is my idle state at the entry level of my state machine. So in my idle state, what I'm gonna do is open it up and search for my animation layers interfaces events, and here is my full body idle state. I'm gonna add it over here. So at upper level we only need that functions, and at the one step down we will add that idle states and functionality. So I'm gonna add it over here, animation player. So if I set that, you can see my character also in a pose, remains in a pose. So for fixing this, I'm gonna create a new animation blueprint. For this I'm gonna call this, go to my animation blueprint and select SK mannequin, and I'm gonna call this animation blueprint underscore layer base. So this is our layer base in which we will add our all the layers functionality. So if I go to my class settings and add interface over here, Lyra interface, and similarly you can see I have all these states available over here. So now here's the fun part. I'm gonna open the full body idle states, and I'm gonna add a new animation sequence player, and for this I'm gonna set the sequence to my bind this and set this to my dynamic value, right? Set this to dynamic value. Setting this to dynamic value and connect it over here in my output pose. So now if I go to my functions, and when this event fires, we have these three functions: on initialize update, become relevant, and on update. On update fires always on tick when our character stays in idle pose. On update is always firing. So we will only set idle animation at one time, so we will use on become relevant function. So I'm gonna go to on become relevant on sequence player, that will be my idle state, and create a new binding. I'm gonna call this on idle state, on idle anim here. So I'm gonna grab my context pin. So we are using here is sequence player. So for this we will get our set sequence with inertial blending with sequence player, not sequence evaluator. So we will use set sequence with inertial blending with our sequence player because we are using sequence player node here. I'm gonna connect it over here, set the return over here. So it is necessary that always your return nodes executes or connects, execution ends with the return node. And for the sequence player, I'm gonna convert the node to sequence player, not sequence evaluator. Here's my sequence player. I'm gonna convert this to sequence player, connect it over here. So now we need to set the animation for this. So let's say we have two idle animations. One is, for example, one is in crouch idle and one is standing idle. For this I'm gonna use select node and search for idle. If I open my animations and search for idle, So here's my idle standing and idle at crouch. So if I set this to select my idle animation when I'm standing, set this to option 0, and standing crouch idle to 1, like so. And I'm gonna set the wildcard to boolean and set this to false. So you can set the condition to your character. You can get the character current state and set the condition according to need. For example, if my character is in idle state, is in crouching, then we will set this to true and false. So for this I am gonna just explain the functionality of setting the dynamic animation. So for this I'm gonna use this to set this to false, which means our standing idle animation should be played, right? So now I'm gonna go to my animation blueprint layer base, which is our this is the Lyra base animation blueprint. Here is idle state, and we have added idle state function over here, right? And in our instance class, if I'm gonna set this to animation blueprint layer base and set it compile, you can see my character is in standing idle pose. So if I go to my character blueprint and set the animation blueprint to layer base, that is our base character blueprint, animation blueprint Lyra base. I'm gonna set this to over my animation blueprint of my character. So here you can see my character is in standing idle state, right? So if I set this to true and go to our Lyra base, you can see our character is in crouch idle state, right? So this is the new approach of setting up procedural animation way. So we don't need to add any states for our crouch idle or any other animation states. We dynamically set the states according to the conditions that we provide. So here's this. So if I take this one step further, I'm gonna right click on my animation layer base and create child blueprint class. That will be my animation blueprint underscore unarmed, right? This is my unarmed animation blueprint. So what this will do, this will also reduce the complexity of our setting up the, for example, if we have rifle idle, pistol idle or unarmed idle, this will resolve all that functionality too. So I'm gonna go to my animation layer base. So if I promote this to a variable, I'm gonna promote this to variable and I'm gonna call this standing idle, right? And I'm gonna promote this remaining also to crouch idle. So if I promote these two variables, these two animations to a variable, now we don't need to open all this animation layer base. We just open our unarmed animation pack, and over here in details panel, you can see asset override, we have idle states and we have sequence player. We need these two variables So if I promote these two animations to a variable, which means technically it should show in unarmed blueprint, animation blueprint, but it's not showing here. I'm gonna delete this unarmed animation blueprint for now and create a new one. I'm gonna go to animation blueprint, and here in my select this mannequin and set the parent class to our animation blueprint underscore layer base. Create this, and this will be our animation blueprint underscore unarmed animation blueprint. I'm gonna save this all, and here you can see this is the here you can see. If I'm gonna go to class defaults, I can set the animations directly over here in my unarmed, so we don't need to go all of the animation states and animation hierarchy to set that animation. So for example, if I set this to run forward, or let's say some other animation, I can directly set it over here. So for this we just need to update our, go to animation base animation blueprint. Here is our idle state, and we just need to update our instance class that will be our animation blueprint unarmed. So in our unarmed animation blueprint, if I set the crouch to false, you can see instead of standing idle I have running animation, or in my standing idle animation. So which means if I need rifle idle, pistol idle, let's say that animation, we only need to create a new animation blueprint. If I'm gonna create a new animation blueprint, select SK mannequin and set the parent class to our animation blueprint layer base, and I'm gonna set this to rifle animation blueprint underscore rifle. So now we just need to set that to our, we don't need to go all of the animation hierarchy, or I set all the states for our new animation states. We just create this animation blueprint and set that animations accordingly. If I go to class defaults, and here I can set the rifle idle or some other animation. So for testing I'm gonna use running animations for now, and in unarmed animation I'm gonna use proper idle animation. So if I search for idle, so this is my male idle. Here you can see I have my male idle animation. So let's say if I grab some weapon, I just need to update the instance class over here, set this to rifle here, and here is, if I set the rifle idle to running, you can check my current idle animation is running. So which means we just need to update the specific animation variables and don't need to go all the class hierarchy to set up our new animation states and animation functionalities. So I hope this all concepts clears to you guys. Let me know in comments if you have any confusion or any question related to this. So I try my best to explain all this functionality in detail. So if I close all this out, I'm gonna repeat all this functionality again. So here's my default animation blueprint layer base, Lyra base, and here in my idle state I have just added first we have created these events: idle states, movement start, cycle, and pivoting, and add that interface to our current Lyra base animation blueprint. And we don't need to set up any other animation here. We just set the idle state over here, and if we are holding weapon, then we set the instance class to animation blueprint rifle, pistol, or if we don't hold any weapon, then we just set the animation blueprint class to unarmed. And here is the result. I'm in my idle state. So this is all the animation blueprints, hierarchy, and functionality in UE5, and we will use that throughout the whole series. So I think this is it for this video. I hope you guys like this video and learn a lot. So if you have any confusion or any question, let me know in comments. I will try my best to explain that out. So I'm gonna end this video here, and in our next video we will start implementing the further functionality that will be our movement start and movement loop. And in this basic video I've tried my best to explain all the class hierarchy and functionality of animation blueprints in UE5 and whole Lyra's breakdown. So in Lyra starter pack or Lyra's animation and locomotion system, they are using all these functionalities and all this class hierarchy to their project. So it's much more cleaner way for implementing or setting up new animations and animation states to your character blueprint and functionality. You don't need to go all the animation states and hierarchy. So that's it for this video. I hope you guys like this video, and don't forget to subscribe my YouTube channel, and also you can support me on Patreon and gain access to all the project files over here. Thank you guys, and see you in the next one. Bye bye.